Quickly guys, before we get into this video, you'll notice that only a few people are subscribed to my channel. So most people who actually watch my content aren't subscribed. So if you do me a huge favor, please subscribe before you get into this video, and I'd really appreciate that. Welcome to Khetztutorials, and in this video I basically just continue where I left off. We are still talking about algebra, and I just want to start with simplification. So this is just a continuation, and this simplification part comes in quite a number of ways, or in a lot of different ways, and you can be given certain sums or certain equations and asked to simplify them. That basically applies to everything and mostly in algebra, right? So let's get right into it. So the best way to explain this, I think, is to just do an example. And this example is actually going to apply some of the concepts which I previously discussed in the previous video. So if you haven't checked that video out, please check it out. So let's say given an equation like this, it says simplify, right? X squared subtract 5x. Okay. So now if you ask to simplify this, the first thing that you do is to change this sign, or let me say the first thing that I do is to change that sign. So you should know by now that dividing is actually the same as multiplying by the denominator of whatever you are dividing by, or the reciprocal of whatever you're dividing by, right? So this is the same as just multiplying this by this, but now taking the denominator to the top and the numerator to the bottom, right? So that is basically the same. Now moving on to what we basically have in front of us, you'll notice that you have a difference of squares over here. So you can change that to, if you remember the difference of squares formula, you just find the square root of the first term and then subtract the square root of the second term, and then square root of the first term plus the square root of the second term. So that is what you have as a difference of squares. And at the bottom here, you have a quadratic equation. Somewhere else, or just next to the problem, you can just compute the brackets for that. So basically here, what do I have with me? So basically here, you can just take the x out, or let's just continue right in line with the question itself, right? So continuing in line with the question, we can basically say that you have 2, and taking out a common factor of, so at the bottom we have x cubed actually. So let me fix this. It is supposed to be x cubed over here. So at the bottom we have x cubed, and we have x, which is common to every term in the bottom term, right? Or in the bottom equation. So 2x squared subtract, we're going to have 7x, then we're going to have that. After factoring out this x over here, and all of that is multiplied by x, so we're going to also factor out x at the top as well. Then we're going to have x subtract 5. Then at the bottom, for now, we can leave it as it is, or we can apply another formula which basically says, so here's another useful tip, or here's another useful formula. So use 4. If you have a difference of cubes, right? If you have a difference of cubes, here's what you do now. In this case, you're going to say the cube root of the first term subtract the cube root of the second term. Then in the second one, you're going to say the square of this, and you're going to put the square of this at the end. Then in the middle, you basically multiply this here and that, and multiply by -1. So x multiplied by negative y is negative xy. Then multiplying that by negative 1 should give you plus xy. And that is what you're going to have as a second bracket. So whenever you have a difference of cubes, you're going to do the cube root of the first term, you're going to do the cube root of the second term, then put a negative sign in between. Then you're going to do the square of that same cube root, which is this. Then you're going to do the square of that same cube root as well, which is that over there. Then in the middle, you're going to multiply this term by that term, including its sign, and then multiply by minus 1. And that is why we have a positive here. So x, for the middle term, you're going to have x multiplied by negative y, and then multiply that by minus 1. That is why we have a plus xy over there. Now, applying this to what we have specifically, you have 8x cubed subtract 27. So the cube root of this part, you notice that this is the difference of cubes. The cube root of the first part is 2x. Then you're going to subtract the cube root of the second part. Then you're going to square this, which is 4x squared. Then you're going to square this, which is 9. Then in the middle, you're going to have 2x subtract 2x multiplied by negative 3, which is negative 6x. Then you're going to multiply that by negative 1, which is going to give you plus 6x. So that is what you basically have currently in there, right? That is what we basically have currently. Now, as we continue, you'll notice that at the top you have x, and at the bottom you have x, so that those cancel out. And at the top you have 2x subtract 3. At the bottom you have 2x subtract 3. Those cancel out as well. So now as we go along, after cancelling those, you should have this left. And we have two quadratic equations, or two quadratic formulas at the bottom, which we can simplify by breaking them down into brackets, right? So let's do this one first, which is 2x squared subtract 7x subtract 15. Let's break that into two brackets, and those two brackets should be, so you can just do it somewhere else, and those separate brackets should be, so factors of negative 30, which give you negative 7, and those factors should be 10 and 3. So basically you're going to say 2x that, then you're going to have minus 10x, then you're going to have plus 3x subtract 15. Then taking the common ones, then you're going to have x subtract 5. Then taking 3, which is common, you're going to have x subtract 5 as well. So the answer to that would be x subtract 5 and 2x plus 3, right? So 2x plus 3 at the top, multiplied by x subtract 5 at the top. And at the bottom, you're going to have x subtract 5. You're going to have 2x plus 3. Then you're going to have this other bracket of the quadratic equation, which we haven't touched, right? Then you'll see that you have that and that at the top and bottom. You have that and that at the top and bottom, which means our result, or our final answer, should be 1 divided by 4x squared plus 6x plus 9, right? And that is your simplification, or that is your final answer after simplifying your original equation. So that is basically what we have in terms of simplification. I just wanted to show you an example. You have to apply what you know about each of the terms in your equation. You have to split all quadratic formulas, and you'll find that in the end you do actually cancel the top and the bottom. You actually have to know the difference of cubes, which I showed you, and that'll be quite useful to you. Now we're going to move on to the next topic, which is simultaneous equations. Now with simultaneous equations, you can get different forms. And another variation of those different forms is the one which I'm about to show you now. So let's say you're given this. Let's say you're given this, right? Let's say you're given 2 to the power 3x plus 1. is equals to 4y, and you're also given x squared, plus 2y is equals to 29. And you're asked to find, so solve for x and y. So simultaneous equations can come in any form, but basically you are solving for two variables at once, and that is what the term simultaneous means, doing two or more things at once. So now we are going to say, taking the first equation, we're going to make sure that the right and the left have the same basis. And you notice that 4 is 2 to the 2, and then you're going to put that exponent which is given to us in the question, which is y. Now multiplying that, you're going to have this 2 to the 2y. Then you're going to create your 3x plus 1 to 2y, which means that essentially you can say that x is equals to a third of your 2y subtract 1. So you're going to take this to that side, it's going to become -1. Then you can divide everything by 3. That is why you have this formula over here. So you can take this as your first formula. So x is equals to a third of 2y subtract 1. You're going to take this to the formula given to us in the question over here, which says x squared plus 2y is equals to 29, right? So substituting the x from this formula, which says it's a third, so you can say it's a third of 2y subtract 1. I'm going to square that. This is just substituting x into there. Then you're going to have 2y, then you have equals to 29. Now we only have y in this equation, so therefore we're just going to solve for y and use that answer for y to find x. So now we have 1/9, then you have multiplied by the square of this 2y, which is going to be 4y squared, subtract 4y, and then plus 1, right? That is just the square, which you're going to find, or which you're going to have. Then plus 2y is equals to 29. So basically, we're just going to multiply through and see what we can do by that. So you're going to multiply through by 9, and you're going to get 4y squared, subtract 4y, plus 1, then plus 18y is equal to 261. Now that we have that, we can just take this 261 to the left side, and taking it to the left side, we're going to have 4y squared plus 14 plus 2, so negative. It's going to be negative, right? So it's going to be negative 261 plus 1, which is going to give us negative 260 is equals to 0. Now all that's left is to find the factors of this, or basically finding the factors of this. So we want the factors of 4. If you remember how I computed the factorization of quadratic formulas, or how I taught that in the previous video, we want the factors of 4 multiplied by 260. That will give us 14 if we add them. So we want, 4 multiplied by negative 260 is what we are aiming for. So the factors of that, so multiplying these two, you basically get 4 multiplied by that is 240, then 4 multiplied by that is basically 800. So we're looking for the factors of 1040, which will actually give you 1040 if you multiply them, negative that is, because there's a negative sign here. We're looking for the factors of negative 1040, which will give you a negative 1040 if you multiply them, but will give you 14, positive 14 if you add them. And those factors are 40 and 20 and negative 26. Now if you take the common factors now, continuing with that, take the common factors, you're going to have 4y. You're going to have 4y, right? Then it's going to be 4y over there, so you're going to be y plus 10. And taking 26 over there, you're going to have y plus 10 as well, which is equal to 0. Then you're going to have y plus 10 multiplied by 4y subtract 26 is equal to 0. Now notice that in this second bracket you still have common terms, so you can take out 2, which is common among those. So you're going to have 2 multiplied by 2y subtracted 13. So when you factorize, your aim is to always make sure that the final bracket does not have common terms. So here the common term is 2, right? And that is why we factored out this 2 over here, so that the brackets don't have anything in common and you can't simplify them any further, right? So in the end, you'll see that your 2y is equals to 13, or your y is equals to negative 10. So you're going to have your y equals to 6.5, or you're going to have your y equals to negative 10. Now we're going to take this y and substitute it back into the formula that said x is equals to a third of 2y subtract 1. And therefore, we're also going to expect to have 2x values because we have 2y values. So x, when substituting your 6.5, you're going to have your 6.5, which is also 13 over 2, subtract 1. That will cancel out with that. Then you're going to have 1 over 3 of 12, which is 4. Right? So that is the value of x when you have x y equals to 6.5, and then the value of x when you have y equals to negative 10. Let's see, you're going to substitute negative 10 in there. Then you're going to have 1 over 3 of negative 21, and the answer to that should be 7. And therefore, your final answer for this would be in the form of, if you have an x of 4, you're going to get an y of 6.5. If you have an x of 7, you're going to get a y of negative 10. That should be negative 7 over there, right? It should be negative 7 because we're saying negative 21 divided by 3. So the answer to that is negative 7. And that is how you basically deal with simultaneous equations. You write one variable in terms of the other and solve for that one variable and use the answer to that variable to find the other one. So we're now basically going to move on to look at inequalities. So let's look at inequalities. Right, inequalities. And with inequalities, here are the 2 things which you have to know. So, or let me just say a few things which you have to know. So one of them is if you divide both sides by a negative, right, then the inequality changes direction. That is one of the most important ones which you have to know. And secondly, we can say that you can draw, so you can draw diagrams to help you solve these problems. So in some textbooks, you'll see that they don't actually go through the math, they just draw diagrams and proceed to write the answer. So you depending on what the question tells you, you either have to actually solve or draw the diagram, or you have to solve and draw the diagram. So just take note of what the question is saying. If you weren't asked to draw the diagram, you can just draw it for yourself, if that is how you basically understand it more, but focus on solving the problem. So I'm gonna dive right into an example to show what I am talking about in terms of the diagram, right? So the diagram is not something which is specialized or which is drawn to scale or something like that. It is just a representation of what you're actually dealing with. So given this inequality here, it says 6x squared plus 13x subtract 4 greater equals to 1, right? So we are going to take this one to the left side of the equation. We're going to have 6x squared plus 13x subtract 4 subtract 1 greater equals to 0. Now you'll notice that the highest power in this equation is actually 2. So this is a quadratic function which corresponds with parabolas. And also you'll notice that your a if we were to write this as ax squared plus bx plus c, you notice that your a is positive, which means our graph is pointing upwards, which means it's a positive graph, right? So we can right away just draw a positive graph which cuts the x-axis at certain points. Now these points are the roots of this equation over here. So here's what we can do. Let's find those roots. Let's factorize this into its roots, and to do that we're going to find the following. So basically going to say that 6x squared subtract 2x plus 15x subtract 5. These are the factors of negative 5 multiplied by 6, which give us 13, which is 15 subtract 2 gives you 13. 15 multiplied by negative 2 gives you 30. From my method of factorization, if you remember from the previous video. So now we can take the common factor over there. We have 3x subtract 1. You can say plus 5. Then you're going to say here you're going to have 3x. If you take out that, you can have subtract 1 greater or equals to 0. And the brackets you're going to have are the following. Right? Now that you have that, you'll see that these brackets actually give you the roots, or these brackets actually give you where the function crosses the x-axis. So if we were to look at this as the x-axis, you see that one of the values where it crosses is 3x subtract 1 is equal to 0, which is x equals to 1 over 3, right? And the other part is 2x plus 5 is equal to 0, which would be negative 5 over 2, which is negative, right? So that part will be on this side, which is negative 5 over 2, and this part will be on this side. So the roots, or the x values from this point, give you where the graph crosses the x-axis. Now that you know where the graph crosses the x-axis, you can answer the question. So now this question is asking us for values of x, or where the total equation, or where the function itself is above 0. So it's asking you for the parts where the function is above the x-axis. So that is where you have positive y values. So this function is the same as y is equal to f of x, or it can be equated to y. So whenever you're asked to find where it's greater than 0, you're basically asked to find where the graph is above the x-axis, right? Because that is where the positive y values start. So to answer this question, you can see that for all values that go in that direction of x, and all values of x that go in that direction, you have the graph above your x-axis. Now for this middle section over here, you'll see that it's actually below the x-axis, and therefore that part doesn't qualify. So the answer to this question is x less equals to negative 5 over 2, or x greater equals to, because the x values to this side are always greater than the x-axis, and the x values to that side of negative 2.5. So that is why we have x less equals to negative 2.5, or x greater than equals to 1 over 3. Now if you were to simply just say take this sign and apply it to both of your values, that would be wrong, because if we study our diagram, you basically can't say that x greater equals to 5 over 2. We can't just take this, right? We can't just take this sign as it is. And if you actually want to solve that, you will notice that you can actually do so by saying 2x plus 5 greater equals to 0, and now 2x greater equals to negative 5, and basically you have divided by 2, x greater equals to that. That would essentially be wrong, right? It would be wrong because you'd be saying that your x is greater equals to 5 over 2, and that would mean you are talking about this section over here. So from this section towards that side, and this part is actually below that x-axis, which means it doesn't qualify to be called something which is above 0. So diagrams are quite useful in that regard. You just have to draw, if the coefficient of your x squared is positive, you just have to draw something like this, and then draw your x-axis, and then find where it crosses, and then give the interval which satisfies whatever the question is asking you for. Now, if your coefficient of x squared is negative, you just draw something like this, and then draw a line, and then here you'd have your x values, and then just give the intervals for which satisfy whatever the question is asking for. That is basically all you have to do in terms of inequalities, and I hope that is quite clear. Once again, if anything is not clear, please leave a comment. If you like this video so far, please give it a thumbs up, and if you haven't subscribed, please subscribe. So now I'm going to move on to exponents, right? So exponent. By now, I expect you to know most of the rules of exponents, right? So let's start. We're just going to do examples. Let's say you're asked to simplify, right? Asked to simplify the following, given let's say 7 to the 0 plus 125 to the power 2 over 3 plus 16 to the power 3 over 4, then subtract 8 to the power negative 2 over 3, right? Let's say you're given that, and you're asked to simplify that. Now, obviously, we are not allowed to use a calculator in this case, and therefore we aim to find bases which are gonna have exponents which cancel with the denominators of these, right? So if you look, okay, so the first thing is you have something to the power 0, which is going to give you 1. Obviously, that is just a rule. Now, what base will give us a power of 3 when we have 125? The answer to that is 5. So 5 to the 3 is 125. Then we're going to carry that same exponent which is given to us in the question. Now, what base is going to give us 4 if we want to find 16? That is going to be 2. Then we carry that same exponent we have over there. What base is going to give us 3? We know that the answer to that is 2, right? So that is what you always aim for if you have a power which has a fractional part, or which is a fraction, right? So that is what we aim for. Now this 3 is going to cancel with that, this 4 is going to cancel with that, and this 3 is going to cancel with that. And in the end, we're going to have 1 plus 5 to the 2 plus 2 to the 3, subtract 2 to the minus 2. Now in the end, we know that this is 1 plus 5 to the 2 is 25, 2 to the 8 is 2 to the 3 is 8. Then that is basically just 1 over 4. Now you can add this up using a calculator or whatever, because we basically just solved this, but you can just right away do it manually. This is 4 over 4, subtract 1 over 4 over there. So 4 over 4, subtract 1 over 4, give you 3 over 4. Then you basically have 8 plus 25, which would give you 33, right? You can add these up using classic formula. Just say 3 plus that, then you're going to have 4 multiplied by that, which should be 132. Then you're going to have 135 divided by 4 as your answer. So that is how you basically simplify these kind of questions. If you're given a fractional part, just look for a base which is going to have a power that's going to cancel the denominator, so you can move on to just focus on the power which is in the numerator. So that is how you simplify that. We're now going to move on to equations in terms of exponents, and we want to solve for x, right? So let's say we're given 5 to the 2x plus 1 plus 5 to the x. So we're also given 5 to the x plus 1. Then we have negative 5 to the x equal to 0. And we're asked to solve for x, right? So the first thing that you must do is just basically group the like terms. If you just split each of these to the following, just split them to that, you're gonna have this 5 to the x multiplied by 5, then subtract 5 to the x is equals to, so you're just gonna take your 1 to this side and call it 5 to the 0, right? You're gonna call that 5 to the 0. And another way you can actually do this is to just say, you can just say let something like k equals to 5 to the x, right? If you let k equals to 5 to the x, I'm going to give you this method as homework. You'll see that you actually have 5k squared plus 5k subtract k, and then subtract 1 is equal to 0, which should give you, then continue from here, find your answer in terms of k, and then substitute k back into the answer to find x, right? But here's a method which I'm going to use. I think the k method is actually simpler, but this is the method which I first saw when I was just doing this. So you have 5x, 5 to the x multiplied by 5, common between these two, this and that. And here you're just basically going to have 1. And then here, if you just factor out -1, you have the same, which applies to us, right? And you're going to have equals to 0. Then you're going to group the brackets and say that. Then 5 to the x multiplied by 5, subtract 1 is equals to 0. Then in the end, you're going to have 5 to the x is equals to -1, or 5 to the x multiplied by 5 is equals to 5. It is equals to 1, sorry. So you're going to have 5 to the x equals to 1 over 5. Now, if you look at 5 to the x, it can never be negative. Whatever you put as your x value should never give you a negative number, which means this is not applicable. This side is not applicable. It's not possible. You only focus on this side where you have 5 to the x is equals to 1 over 5. And 1 over 5 is actually equals to 5 to the -1. And therefore, your x is equals to -1. And that is basically how you'd find your x in that particular case, right? That is basically how you'd find your x. I'm now going to move on to talking about the types of unsurds, or the types of numbers and surds. So this is going to be useful to you. Let's talk about the type of numbers first. Let's say you're asked to find rational numbers in a certain question, irrational numbers, and parts where something is not defined, or you're asked to find non-real answers. Now, irrational number is basically something you can simply show as a fraction, like a divided by b. Now, in an irrational number is basically something which you can't show as a over b simply, like pi, because pi is 3.14 something. You can't specifically change that into a fraction or show it like it can have a definite fractional representation, and therefore qualifies as being irrational. Now, when something is not defined, let's say you had 1 divided by x subtract 3, that is basically when the denominator is equal to 0. So x subtract 3 cannot be equal to 0. So if you're asked to find the values of x where this is undefined, you basically just say x subtract 3 is equal to 0, so x is equal to 3. So x cannot be equal to 3 because at that point this equation would be undefined. Now, if you're asked to find non-real where a certain equation is non-real, that would be when you have the square root of a negative, right? And that would be when x, in this case, that would be when x subtract 1 is equal to 0, or x is equal to 1. So if you substitute 1 over there, so that at that part you actually have okay, so I'm going to say less than 0, not equals to, right? So if x were less than 1, then all the values less than 1 would basically give you it will be greater than 1 in this case, because we are looking for something which is going to give you a negative. So a negative would result from something which is less than 1, right? And x would therefore be greater than 1 in that case. So x subtract 1 less than 0. So x would have to be less than 1. And an example of something which is less than 1 is 0. So if we were to substitute 0 over there, you have the square root of negative 1, which is non-real. Right? So that is just an explanation of the types of answers which you can get. We're now going to move on to the last part, which I want to talk about in terms of algebra, which are surds. So basically, when you have the square root of something multiplied by the square root of itself, whatever power it may be, you basically have, so if it's just a square root, you have x to the power half, and you also have x to the power half, and multiplying these two is the same as just adding the exponents, which is basically that. So square root of x multiplied by square root of x is actually equals to x because of this, right? So even if you had the cube root of x multiplied by the cube root of x, or maybe you had the square root instead of here, you basically just add the exponents, right? So x to the 1 over 3 multiplied by x to the 1 over 2, and you'd add these up to find the answer, right? So that is what surds are all about. You have mostly have the square root sign, you have the cube root, or whatever the case may be. So let's say, for example, you're asked to find the product, or you're asked to multiply two brackets, right? So here's how you do it. You say 3 multiplied by 3, which is 9. You'd say negative square root of 2 multiplied by square root of 2, which should give you negative 2. You'd say negative, negative square root of 2 multiplied by 3, which should give you negative 3 square root of 2. Then negative square root of 2 multiplied by that should give you negative 2. So now you'd notice that you actually have, let's look at this properly. Here you'd have, let's do this again. 3 multiplied by that is 9. 3 multiplied by that is 3 square root of 2. Then this multiplied by that would be negative 3 square root of 2. Then this multiplied by that would be negative 2. And in the end, you just have 9 minus 2, which is 7. You don't necessarily have to do this in this case, because if you look at this, I'll just write it again. It's a difference of 2 squares. Alright? It's a difference of 2 squares. You notice that if you square this, you get 9. If you square this, you get 2. And you get 7 over there. So just look out for that. Don't waste time trying to expand things if you can just simply find out that it's a difference of squares, or whatever the case may be. Let's say now you're asked to simplify the following. Let's say you had square root of 12 plus square root of 27 divided by square root of 75, right? So now that we have that, we can actually find factors in here of each of the values which we can compute the square root of. And for 12, we can compute the square root of 4, and 12 is 4 times 3. And here at the bottom, we can compute the square root of 25, and that is 75. It's 25 multiplied by 3, and here we can compute the square root of 9, and 27 is the square root of 9 multiplied by 3. So in your factors, you always aim to have something which we can find the square root of, and the result of this would be 2 multiplied by square root of 3. We can't find the square root of 3 in here, so it stays as it is, and the same applies to the next one over here. So you're just going to have 3, which is the square root of 9 multiplied by the square root of 3. At the bottom, the same thing applies. 5 is the square root of 25, and we just leave that as it is. So now you basically can just work with this. So at the top, it's actually addition. I made a mistake over there. It's actually addition over there. So you can just do that. It's actually addition. And therefore, we can say that you have 5 square root of 3 at the top and 5 square root of 3 at the bottom, and the answer to that should be 1. So that is how you simplify surds. You just, if you have to multiply them or whatever the reason may be, just find a factor of the number which is inside the square root, which you can find the square root of and multiply it by something else, and find the square root of that value inside, multiply it by the square root of the other one which you can't compute the square root of, right? And that is, I basically covered a lot of things about algebra, and I hope all of that was clear, and I hope all of that was helpful. And if you haven't subscribed, once again, please subscribe. If you like this video, give it a thumbs up. And yeah, I will see you guys in the next video. If you have any suggestions, if you have anything which you want me to put up on my channel, please don't hesitate, email me or leave your message in the comment section, and I will see you guys in the next video.